Okay, we got everybody wired up?
Yep.
Okay. Well, thanks. Thanks for staying so attentive, and this is our first panel of the afternoon, second of the day, the second of four we're going to have over the course of 2 days. So I think we have a lot of variety to show. I can't tell you how delighted I am that I was asked to moderate this panel. I think the real reason was Joel and Spaff knew that any intelligence I had was truly artificial. So it was just a matter of trying to find the right person to be the moderator for this. So I think we've got a fabulous panel. This is a panel that's got a broad range of experience. And so I'll just give a brief introduction of each of the panelists, and I'll let them talk about their work here in a second. Starting on the end, Professor Julia Reyes. She's with the Purdue University Department of Computer and Information Technology and also a CERIAS Fellow. Her primary research interests lie in natural language understanding, knowledge discovery and representation, as well as uncertainty management, which I like the sound of that. She's also done some very interesting work in computational detection of humor, which you don't see on everybody's resume. Next is Rob Hale. Rob is a Lockheed Martin Fellow. He's got over 30 years of experience in IT operations and cybersecurity. In his current role, he's leading advanced research and development activities in hardware-enforced embedded security, malware reverse engineering, and information weaponization. I find it interesting that he's sitting next to Professor Reyes because I'm wondering about the cross between humor and information weaponization. That might be an interesting study. Ravi Srinivasan is a vice president. Whoops, I missed going down to the end. He's vice president, IBM Security, and he leads the information risk and protection strategy. He's a frequent speaker at conferences and has consulted with a number of senior executives around the world on key issues of cybersecurity, risk, governance, and compliance. Chet Wisniewski, second from the end, is a principal research scientist in the office of the Chief Technology Officer at Sophos. He's been working in information security since the late 80s. He has also spoken at a number of national conferences and around the world as well, consulted with a number of leading media outlets. So before I turn it over to the smart people on that half of the room, what I want to do is really just give a little opening statement about the fact of where we are with artificial intelligence. There's no argument that in recent months, artificial intelligence has become, in some cases, the darling of the IT industry, and in other cases, it's been approached with a great deal of caution. So while AI is really just beginning to have an impact across the spectrum of information technology, it really does appear from a lot of the articles that I've seen and read that the next big growth opportunity for AI, both in terms of impact and technology, is going to be in cybersecurity. So it's well known that there's a shortage of talent, shortage of resources in the cybersecurity space. And so people are looking at all kinds of new technologies to help us bridge that gap and solve the problems. But, you know, we're asking our human professionals to spend a lot of time sorting through tons and tons of data, both structured and unstructured, trying to make sense of that while still watching for those anomalies that are out there to try to figure out where that next attack is coming from and how we can protect ourselves. Now, AI can help with that. It can stay vigilant 24/7 by 365, but how do we work it so that we can train it well enough so that it can be as effective as its human counterpart in terms of making sense of what it is actually seeing? And for that matter, what role will AI play for the adversary as well as for the defender? So we want to make sure we talk about both aspects of that. So I'll ask each of the panelists, and we'll just go in order. This time we'll go in the correct order. And I'll have maybe Julia start, and she can talk about your vision for the use of AI in cybersecurity, maybe touch on benefits and issues in the broad spectrum in addition to the work that you're personally doing. So Julia?
Thank you, Jerry. Let me start with repeating what Jerry said. My research is natural language processing, natural language understanding, knowledge discovery, as well as knowledge representation. Just like security, it is extremely hot topic, and a lot of companies are trying to do various things to get as much information out of data and trying to get it into a form that a human can match computer understanding to whatever it is that computers can do. If we are looking at AI, an average person is getting their knowledge of AI from science fiction, let's face it. Most of us are not going to take AI classes. So we are watching movies, we are reading popular press that is giving us some feedback about what kind of software exists right now. what kind of tools exist within the artificial intelligence, and most of the AI knowledge gaps that a regular person has, they are going to fill in from the knowledge of science fiction. Thus, we are getting a lot of misconception of what AI can actually do versus the expectation of what we want to do and what we can get out of AI system. Having said that, we can break a general problem, if you will, of cybersecurity into two things. One is detection prevention, and another one is user education. User is where most of your trouble is coming in if you are talking about the security system. Most of the users are not as well educated as we can get them. Now, AI systems are absolutely terrific, not about reasoning, but about getting information that exists from the web and flowing that information in a kind of a form into a user, provided that the user knows what to ask. So if we are looking at the prevention or detection aspect of an AI system, and we are looking at a fairly knowledgeable adversary, the odds are AI system will not be useful in the top cases. Yes, we can train the system to detect whatever is known already. Machine learning is wonderful, especially if you provide enough sample, enough corpus, enough data that it can get some of the patterns. And if your information technology professional is trained in some of the machine learning and AI algorithms and know how to handle various anomalies, if you will, the algorithms can pick it up. But for a very smart adversary, AI system is not going to be much of help. Again, going back to the educational aspect, it's going to be great if your user is saying, maybe I am getting a virus on my system, I don't know what to do, my software tells me click this button, should I or should I not? That's when the system can help. If we are talking about phishing attack or spear phishing attack, God forbid, we are not quite up there to get to the information where AI can be useful. So it's sort of in the middle, if I were to answer that question. It can be useful if you know how to use it, but don't rely on it at 100%. Thank you.
So I'm one of those ones that's guilty of watching way too much science fiction and reading too many of those types of background materials. One of the things that we do, that we've been working on at Lockheed, and this is kind of where our bases come in, we've not really referred to it as an artificial intelligence kind of concept, but rather dealing with autonomy, autonomous systems and automated systems, and the differences between those two, and really looking at the ability of a system to be able to act and function autonomously without the advent of any kind of human intervention. That's really what we've been looking into, and doing a lot of our focusing a lot of our research on. One of the things that we run into, and some of the areas that I have concern with this is, one, I have on one side I'll have all the Skynet disclaimers that people are concerned that, okay, we're going to create an army of drones or something like that that are going to be able to talk to each other, and eventually they will gain sentience and destroy Earth as we know it. To which I've got a really good philosophical argument that we can talk about offline. But more importantly, it's how do we actually get to the point where we can make use of these machine learning systems, and to the point where we trust them enough and prove it enough to allow the human beings behind it to say, okay, I will go ahead and let that fly. That's really where I see the biggest problem, is that validation, that verification step that needs to go on to give us the sense of ease that we have to be able to deploy it, much like the way we use tablets or things like that, where we won't take a look at it and say, oh, and consciously suspect it of possibly being wrong. Now, that's also a big fear from a computer security perspective. I mean, let's face it, the moment that you stop looking at something and you start trusting it implicitly, you start having your security issues crop up at that point. So it kind of gets us away from this model of trust being a binary equation of you're either trusted or untrusted. You've got levels of it that go in there, and it really gets into how do you do the operations analysis to say, okay, it may only work, it may only hit an 80% rate, but it does it so much faster than a human, we can accept that, and it's going to correct its problems faster. It's going to do those types of things. So that's really where my concern is how do we get it to a point where we can demonstrably prove that it's as good as what a human would do in that environment.
At Sophos, we're looking at, I guess, a blend of things that you've both spoken about, and so I feel better now. I was worried I would have too much to say, and some of it's been covered really well. But it's sort of a maturity model to a degree as well with how we're using these tools. So I look at the problem we have in our labs of trying to analyze data, and I thought it was summed up brilliantly at DEF CON this year when they had the Cyber Grand Challenge. The winners came up on stage at the end to talk about their perceptions of how their AI had performed in the contest, and they kind of talked about the AI of chess-playing computers and how that's evolved over time, right? Like, for the longest time, the computers couldn't beat a grand champion, right? But they certainly could beat most of us. They were better at chess than almost any of us in the room, probably, even though we're probably a more than above average room. But they couldn't beat Garry Kasparov, right? And then we got to the point where the maturity increased of that technology where it was able to beat the grand champion. But then it became AIs versus AIs beating each other. Who had a better AI, right? Now we've evolved beyond that to another level of maturity, which is a human with the AI can beat any AI. Because the AI is only good at one part of it, and humans bring something else to the table that we've yet to ever quite figure out how to do descriptively with programming, right? And I think that's what we're going to see in our space as well. And we've already been experiencing that in our lab, right? Like, we get 350-odd thousand malicious file samples every day. Obviously, humans aren't looking at those. We had to build systems to help us weed through it. And the early systems, the first stage of that was get rid of the easy part of the problem. The 80% that the computers can knock out automatically for us allowed our humans to focus on a much smaller problem, but it was still a pretty big chunk of the problem that the humans had to deal with. And I think we're just entering stage 2 commercially, not just us, but vendors in general looking at these problems, where we're kind of moving from just machine learning and more into intelligence, right? Machine learning was just teach the machine to detect patterns to limit the number of things that people had to do. Now we're seeing our systems getting into that equivalent range to humans at the basic task, which still won't solve what Julia was talking about, the phishing attacks, these types of things, but it is solving just like the humans getting 97% of the problem most of the time, the hand-tuned systems, now our automated systems are matching that. And in fact, I saw one of the female students' papers at the posters last night in the Women in InfoSec event. They were showing off their research showing that they were achieving 97 or 98% malware detection of Windows executables using their research. And we're there now, but I think we'll get even better when we go to that third step where we figure out how the human can augment that and take us even further, right? Because we got rid of the drudgery, or if we burned down the haystack and we're looking for the needle now in some ashes instead of this giant big problem. That empowers the humans to do much more interesting research and solve much harder problems, because we've been putting out fires for so long. We've never had the human intelligence available to really tackle these problems at a level that we can accomplish, I think. So that's kind of my perspective and my experience working with what we're doing, and I find it pretty exciting. I have no Skynet nightmares.
Thanks, Chad. Hi, good afternoon. I'm Ravi Srinivasan. I have one of those systems that beat the Grand Champ at IBM. So it's been an exciting journey over the last 3 years teaching Watson the language of security. And at IBM, we've spent a lot of time, because for us, we see, and we don't really refer to it as artificial intelligence or machine learning. We actually call it cognitive, because of that system's ability to learn, reason, and for a human to interact with that system in a natural language experiences, right? For us, the key challenge that we see is the ability for teaching that system, giving it access to a lot of sources of information. It's easy to get access to a lot of the structured information, threat feeds like Chet's company, and all of us, we can feed structured data and threat intel and keep chasing a lot more sources of data. But it's the unstructured data. That's the information that's in the wild, the blogs, the news articles, the timely pieces, being able to constantly learn and process them and being able to reason back. That's an opportunity for us. And we're right now doing practical implementations right now of taking a phishing attack and watching how a level 1, level 2, level 3 analyst will work it, and watch how a cognitive system would work it. And just a couple of weeks ago, we found in a very large enterprise, a level 2 analyst saw a phishing attack and saw it and said, you know what, that's downloaded onto a laptop, and that's our patient 0. And we'll call that and say, well, we need to go fix the laptop and update the security capabilities. We gave the problem to Watson and said, so what do you think, right? And the interaction came back saying no, that particular phishing attack, after primary, secondary, and tertiary level of analysis, coming back saying, hey, this is linked to a Cozy Duke advanced persistent threat. So it's a bigger campaign that's being run worldwide. So as we are looking at applying practical technical capabilities like cognitive to this problem of security, we can go beyond the traditional, can the machine learn and simplify a lot of the 80% to now addressing a lot of these complex problems. Because we are living in a very interconnected world. Every company that I go visit around the world that says, oh, we're a regional company, only to find out that they have a website, and guess what? If you have a website, you're not a regional company anymore. So I think the biggest challenge for me, as I see it, looking at it very practically from applying cognition, is getting access to unstructured information, learning, teaching the system. And we've come a long way in teaching it. I was joking. 3 years ago, when we started this training of Watson, we would say, what's a backdoor? And Watson would refer to a backdoor of the house. Right? Those are all terminologies that aren't new, that's new to the language of security. But now that's the key opportunity for me as I see it moving forward, is the teaching a cognitive system to be able to be an advisor for analysts.
Great. Thanks, guys. That was a great introduction. I hope it gave us some things to think about. Let's start with some audience questions. Hopefully there's a couple out there that would like to be asked. Good. Rick, would you mind using the microphone? Is that an issue? That way we get you recorded. No.
Caught on tape.
My question's basic. Are we talking about analytical data you're using, or are we actually talking about intelligence? Because there's a difference, isn't there? Statistics as opposed to learning?
I'll take a shot at that. And then I'll allow people much smarter than me in the area to talk about it. But I kind of break it into two sections when I'm looking at it, and when we've been looking at it at Lockheed. We think there's a difference between the augmented human kind of concept, where you're dealing with being able to drive large statistical patterns, those types of things, as opposed to what we've been trying to get to, which we're trying to get to the point of decision making, actual decision making on behalf, whether it's based on statistical patterns or not, getting to a point where those decisions are being made autonomously without the human in the loop. Put the human maybe on the loop, but we're looking at things that are going to happen at at the kinds of speeds and over the types of connections that we've got that you almost are not going to be able to. You may not be able to have a human in the loop in time to make those kinds of decisions. And so that's where we're trying to press to from a Lockheed perspective. Having said that, that's a bridge way out there still, getting to the point where you're able to get to the decision making, and then like I was talking about earlier, then trusting the decision making.
So it's sort of along the lines where they're driving the cars autonomously and they're driving the trucks now autonomously?
Yeah, to that kind of point. One of the things that we've been working on, which has been reported openly, for example, is this idea of being able to place at the sensor level. Think of sensors, everything from gyroscopes or accelerometers, all of those types of things, where they're able to independently evaluate and validate the level of trust of their neighbors, and understand in ad hoc fashion, create those kinds of networks and be able to do self-reporting as well as reporting on their neighbors from that perspective, so that they can then start to remediate problems at the endpoint source before it ever escalates higher up into that, up the chain in the system. So we're looking at that from those kinds of perspectives as just one example, especially with the cybersecurity side of things, as one example of things, because anytime we get to where we're talking about something that's happening at like an operating system level, or like on a host on a network, that's way higher than we're trying to solve. We're actually working on things that are down at the base hardware levels.
I think the car comment's interesting because I experienced a little bit of how immature that is on the way here. I drove down from Michigan yesterday, and my rental car has this lane departure system built in. And when I came into the construction zone on 469, the construction people were waving me onto the breakdown lane to go around their barricades where they were pouring concrete. And I'm driving off across the yellow line into the breakdown lane, and the car is pulling me back toward the construction workers. And I'm fighting the car back to go, no, I mean to be over here, right? Like the systems are reasonably dumb, at least the ones we have deployed at the moment, and absolutely need a supervising adult. But I mean, that could go either way, right? With a competent handler, those systems are an incredible benefit to safety. With somebody who's trusting of the system, it's just going to do it, results in like the guy that was killed in the Tesla that wasn't paying attention, doing his job, manning the system, which is required at this point, right? And certainly, at least with our systems, I mean, we don't have Watson. But we're seeing, I think those two things that you mentioned, sort of the analyzing patterns versus making decisions, they're related, right? Like our malware analysis systems have been just analyzing patterns, and we got them to analyze patterns well enough that the humans don't really need to look at the patterns anymore. The computers are pretty good at it. Now what we're trying to do is get the computer to understand, these are the outcomes, and we don't care how it got to the outcome. Ignore the pattern. This is the outcome you're trying to prevent. If the outcome is this thing, block the sample, whether you've ever seen a pattern like that before or not. Well, we want you to understand what the outcomes are and make decisions on that rather than the patterns. But you start by identifying the patterns because you can start to teach it all the possible outcomes once you've fed all that in, right? So now we're going, okay, this is what the machine thinks of these things. Now we can explain to the machine the outcomes that those patterns resulted in, and take it, start building those layers up on that data analytical framework that you've already built.
If I may jump in, I read an interesting quote yesterday. If a typical person can do a mental task with less than 1 second of thought, we can probably automate it using AI either now or in the near future. Mental task with less than 1 second of thought. Do you call it intelligence, or do you call it, a response based on the data that you had before? So if we are having somebody who is quoting that this is an instance response that AI is going to be capable of, whatever we call it, probably we are a long way into making some kind of progress anyway. But there is such a thing as common sense. A lot of us are capable of making common sense decision, again, in 1 second or less, which computers are kind of meh. Perhaps Watson. But not that great at it. So again, moving towards intelligence is going to be an interesting shift, but it will probably happen rather slowly, slower than we would like it to be.
Additional questions? We have time.
So you guys have mentioned this with security, and a lot of times, you make a 60-foot wall the bad guy's going to build a 70-foot ladder. Has there been thought into how this is going to step up if you're using this AI to help detect attacks and prevent virus infections, all this malware and stuff? Have you guys thought about what that'll be causing the competition, i.e. the bad guys, to do in response? And are there, I don't know, any considerations to help kind of mitigate the response time of getting these, improved attacks?
Since we do malware stuff, I'll start on that. It's already happening, so yes. I mean, people are trying to poison the data that we're using to train the systems intentionally to either make us intentionally miss things or to make us intentionally misidentify things so that we have to back off, right? So we've seen people intentionally trying to inject, say, lookalike files to Windows files or Microsoft Office files into data feeds that are public, trying to hope that AI will misidentify Windows as malware, and then you'll throw out the AI because you can't use it if it's going to flag a legitimate program, right? Because false positives are a major concern. And sadly, it's very difficult to get a large data set that you actually know is clean. And I've seen a lot of interesting research out of universities from students where they'll analyze 1,000 known malicious samples and do an algorithm. And it's interesting work. But what if you have, I don't know, 3.5 billion files of which 15% may be booby-trapped, but there's no way to know because there's 35 billion of them. No human's going to go through and figure out which ones are which, right? So now so you almost have to design systems to detect the fraud on the feeds independent. It's another component of those layers that you're building up, right? And that's incredibly complicated, and that's an incredibly interesting piece of research, is trying to figure out how to prevent sabotage of the system. Because if you want it to be autonomous, it's got to be able to take any input and come out with the right output.
Yeah, I think this is one of the areas where there's going to be a lot more research that's happening in the field. Clearly, proactive security controls, moving security controls more to the endpoint, being able to apply the same sort of cognition, not at the server side, but at the endpoint level, is going to be an opportunity for growth as well.
It also is going to force us into going back to kind of what I consider full spectrum. I'm going to show some of my age. Go back into more of an information operations kind of concept. Yeah, the adversaries are going to have this, and you're going to have different levels of expertise depending on who you're talking about as your threat agents. I mean, your nation states are going to be a lot more capable of doing this kind of thing than, say, to quote our president, your 400-pound guy on his mom's couch. But at the same time, there are other levers other than technological that you can pull in the defense of your systems, that while you're going to have these, you're going to have adversaries that have them, you can start to do things to make it, for example, more computationally expensive, or you can do things that will shut off other areas of how they're able to get those systems in place and able to use those systems. Going back to the poisoning of data, there's always the opportunity of poisoning data on their side from a learning algorithm kind of thing. So I mean, there's a lot of different options, and I think what it's going to do is it's going to force us to continue to look wider at the holistic component of how we defend systems. It's just going to happen faster.
Oh. Thank you.
I'm curious, what kind of communication between AI systems do you see evolving as perhaps you have a snapshot instant in time analysis from one AI system says we got something bad going on, but before we shut down via SCADA, a different system that is looking at historical, what's the likely next step, indicates it may not be as bad. If the two systems vote, they disagree, automated, I don't know, it subs it out to Watson to get a final say?
We'll stay out of the, we'll provide the decision, but the enforcement will happen locally. And It is a distributed problem. This is where most of the research that we're doing now is how do we apply cognition at a distributed endpoint level, where look at IoT security. What does IoT security mean? Can you enforce security in the communication at the gateway? Do you do enforcement at the device itself? And so there's a lot more work that we could do right now in terms of group your IoT devices into small, medium, large. Small ones do the enforcement at the gateway. Medium ones do it at the local centrally. And then the large ones, you've got to do the enforcement locally at the on the device itself. And so that's where we're looking at a lot more research at this stage in time. It's a very good question.
I mean, you're kind of trying to teach the AI to assess risk, which sadly in our business, as much as we'd like to think it's technical and it's quantifiable, it's actually qualitative, right? Like risk is a qualitative assessment, and that's the bridge we're trying to cross with the AI, I think, right? We're trying to figure out how to teach the machines to make qualitative judgments. We already know how to make quantitative judgments with machines, but that's not good enough. And I think the answer to that, two things disagreeing, I mean, normally, well, which one has a higher score, right? I mean, but that's quantitative, and sadly, well, I wish I had the answer. I'd have a startup.
But don't forget about the human in the loop, right? The collaboration between AI and human is probably the most powerful thing that you can get. So if two systems disagree and you can afford to go to a human analyst, do it. Maybe a system can learn something from it, assuming that you can afford to spend that time to go to a human.
If you can't trust SpaffBot, go to Spaff.
Hi. It was mentioned earlier in the conference just the different types of attacks that are becoming more prevalent, the diversity between an advanced persistent threat or just kind of general malicious attacks. Is there any desire, or what kind of direction do we think artificial intelligence is taking in forms of security to separate those kinds of detection? Do you hope to detect and differentiate between a persistent threat versus just a generic kind of attack, or are you hoping to handle all of those in the same way?
Yeah, if I look at the the approach that we've taken is not to distinguish types of attacks, but solve the problem in terms of that primary, secondary, and tertiary connections. And each one of them will give you insights. The primary one would tell you that this is a type of an attack, and then the secondary one will tell you this is the connectivity that's going to potentially have a midterm impact, and then a tertiary connection will tell you you're now joining a part of a worldwide campaign by the bad actors, and you're just part of the campaign now. So I don't think we're doing any of the break the problem down and say this is a tougher one, go solve this first, and simpler one, automate it and take care of it.
The actions you're going to want to take, though, are far different and can provide
True.
you much better decision-making ability, right? Like, differentiating them is important, because if it's just another banking Trojan, blocking it and moving on is just fine, right? But if it is a truly advanced threat and you manage to detect it, then the decision tree gets incredibly complex very quick. Like, do I want to block it, or do I want them to think they succeeded? And can I contain what they're after and allow them to continue to operate and waste their time while I put in remediative measures on the thing they're after? And can I identify what they're after? And if they are, can I now look for other ways that they may be after it? Like, those kinds of decisions you can't make if you don't differentiate between them.
Yeah.
So I don't know that you'd necessarily want to automate a reaction necessarily, because the unpredictability of your human response keeps your adversary on their toes.
It's Jim Byers from Lilly, and I want to ask a way more basic question than this. So, we've been talking about AI for 15, 20 years. What's changed? Because now it seems to become the language du jour. So what has changed so much that's now bringing this back into the forefront?
$10 on Amazon solves amazing problems. I mean, computing power for us. Like, we couldn't build the systems we have because we couldn't afford it. Not because we didn't have enough revenue, just there wasn't enough power in the power plant to run the systems that we would have had to build that we now can literally do on the cheap. I mean, I do half of my research in $5 digital ocean droplets. I mean, it's astounding what I can buy for such a little amount of money. So for at least from our perspective, it's been purely a cash issue. We've envisioned what we wanted to do for a long time, but we had no way to execute on it to know if it would work because we could only test in the micro. And we couldn't throw those billions of samples at something to see whether we actually had something that would accomplish what we wanted until the last few years.
And the availability of the billions of samples that are now, everything is online, right? You can get that data. We're all complaining that clean data is impossible to get to, but you have at least some data that you can play with and see what happens, which we didn't have before necessarily.
And maybe motivation to cooperate and share that data as well. Like
Yes.
a lot of us
Yeah,
have
that's true.
hoarded data for years and not shared that data. And we're starting to recognize that it's not the data you have, it's what you're doing with it. So more and more
Yeah.
I'm finding it opening up. Like we're seeing more sharing of data than we've ever seen before. We're not very good at it. We still have a lot of work to do, but we're getting better all the time.
Yeah, I think the other part of it is that natural language processing has helped too. Makes it more practical for us to be able to interact with a system. And then you get all these students saying, ask this question. Let's see what would we get as hypothesis back if we ask these questions. So 10 years ago when we did AI, it was the algorithm that's going to get embedded in a tool, and it's not going to see the light of day because it's happening behind the scenes. And now with the natural language processing, now you can interact with that system.
So, just one more question around this. You know, they're starting to have some dialogue around societal impacts, right? What's the job destruction that will happen in this space? So, kind of what is your thinking as you start looking out in your crystal ball? What do you think that impact is going to be, and are there going to be other jobs that people are going to be able to do? How do you think that's going to play out?
Oh, I'm eternal optimist. This is going to be an awesome opportunity for what we've coined new collar jobs. Not blue collar, but it's going to be clearly, I mean, look, any stats that we've seen, I think you've heard it throughout the day about skills shortage. There are over 200,000 job openings in cybersecurity in the US. Expected to grow to 1 million job openings by 2020 around the world. Just the fact that you need humans to interact with these systems and engage in doing research, investigation, being able to analyze and provide insights, that's the kind of roles that we're all going to be playing. And so this is actually not destroying jobs. Actually, it's going to create some very interesting types of industries and opportunities for people.
I would agree with that. I mean, it's I'm also, I guess, a cynical optimist from the standpoint that I don't know that we'll see it explode in the next 5 to 10 years. I think we're going to see remarkable growth, but I don't see a huge, large-scale transformation of, I'll say, the workforce over that period of time. I think we're going to see we're going to see stair steps to that because just the adoption process, I think, is going to take longer. And there's some bridges that we still have to cross as we go forward. But to your point, I think there's going to be some really, really jobs we've never even thought of that are going to be coming out of this that will help offset some of that. Again, the shortages that we have. I mean, one of the things we've been looking at. I mean, okay, I'll thump the Lockheed horn once. We just did a demonstration with an F-16 as a drone, pilotless F-16, where it was basically, it's semi-autonomous in the sense that it does a lot of the things autonomously, but it was basically as a wingman kind of concept, and it was a proof of concept that we did as a prototype. We have support from a lot of the pilots simply because there's not enough pilots, and yet there's a need for more and more of this type of aircraft. So we're getting to a point where we're not going to necessarily be putting people out of jobs but rather making up that gap like you were talking about. We're going to be making up some of that employment gap. And I think you're going to see that in a lot of industries. There will be some that suffer. That's going to happen. There's always that during any kind of revolution. But I'm optimistic about it. I think we'll have some really new, interesting things.
It's also a big reduction in repetition and boredom.
Yeah.
I mean, there's so many things that are actually incredibly boring, and if you can give somebody something more intellectually stimulating to do, I mean, we have retention problems in our research groups for the people that have to do the repetitive work. They leave. If we can't give them interesting projects, they leave. But the repetitive work had to be done until the machine started doing it. And so we were always struggling with that because it required this incredibly high skill and this incredibly boring job. And nobody with that kind of intelligence and skill wants to do that boring thing. And so we're kind of excited that we're going, wow, we're going to get like 75 researchers back to actually go do interesting research, which makes us more productive, makes them stay because now their career's rewarding. And yet the thing that we need to, the basic stuff that has to get done to make donuts, like it's done. And that's another aspect of it, I think, is getting rid of some of the drudgery for some jobs.
My name is David Goldbranson from Raytheon. We've been talking a lot about AI as it is currently, where we've got these, as you say, compute resources are so massive that you can't even host them yourselves. I don't even want to imagine what's behind Watson. But what is it going to take, and is it even on the horizon of where these can be embedded on endpoints that are actually able to make these decisions? Obviously, they wouldn't have the ability to learn from all the other endpoints out there, but maybe they get patches, with all the new learning. Is that even on the roadmap? What's it going to take to get that point where you have a lot of that information available locally? Even things like you have Google Home and Amazon Echo that still is uploading everything to the cloud to make the decisions and coming back. Will we ever get to that point in a reasonable time of where all that can be done locally?
Yeah, good question. I think I would say for like these larger IoT devices where there's large amount of data being processed locally, uploading it to the cloud and having it come back with a decision is not going to be feasible. So those are the ones that'll first be the candidates for getting local security decisions done on the device itself. I think automobiles are first in line to do that already with a lot of work that's being done in that market.
Your iPhone has 4 times the computing power and 10 times the memory that my desktop PC I got when I started researching at Sophos had 13 years ago. So if that pattern continues, I don't see why not, right? I can't believe that there's 4 gigabytes and 8 cores in my pocket.
Yeah, I would agree with that. I think that we're already seeing a lot of at the hardware device level, a lot of the advances have been made, especially now that you're getting down to 7 nanometer. You've got a lot of additional computing power, storage in such small, dense packages that you're able to do an awful lot more in a very, very small form factor. I really think that we're seeing it now, and that's just going to get more efficient as we go along.
And those things can be meshed, right? Like
Right.
there's some
Yeah.
vendors I've been
Yeah.
talking to that are looking at, like you mentioned sensors earlier, and
Yep.
like detecting that, hey, if the pipeline sensor here says the temperature is this and the pipeline sensor here says the temperature is that, and the one in the middle is like off by more than 20 C, it's probably bad input.
Yep.
But that's sort of a collective decision of a whole bunch of really dumb things that collectively have just enough power to work together and go, yeah, that's not right. Alert a technician, it's time to replace the sensor, and well, we just created a job. Somebody's got to go fix the sensor.
Up until now, most of what you've been talking about has been defensive uses of AI. Do you envision a world where AI techniques are going to be able to be used, or AI human hybrids be able to make adversaries substantially more capable of attacking the systems as well?
I think so. I think that, again, on a, it's a build a better mousetrap concept that, I kind of alluded to earlier, that, there is those techniques are going to be available to the adversary. They're going to have the same kind of ability to use the new computational density, the new, the new natural language processing programs, those types of things to start building AI and using it for ways to learn how to attack systems better, or using it actually for having the systems themselves learn how to attack themselves better. So I think we'll see something like that.
And how do you know that they're not out there already?
Right.
Maybe they're good enough that they just act as a human.
Yeah.
Didn't claim they weren't out there, just asked you what you saw in the future.
Thank you. Can you make money at it? Somebody will do it.
Yeah, exactly.
Yeah.
Building up on the previous questions, if you're using first order logic to model your artificial intelligence, is it possible to use unsupervised learning to make sure that the intermediate queries aren't malicious, or is that still being inspected manually for the base queries?
Well, you can add first order logic to anything, as by itself it's probably not going to give you an answer. But in addition to something else, yes, you can add machine learning on top of it, and you can do anything you wish. How imaginative are you? And then see if it works on your data set. Go from there.
Okay, great. I really appreciate everybody's questions out of the audience. I think that has done a couple things. It's opened up some avenues that prevented me from having to ask the questions I had, so I really appreciate the participation. It was great. I think we'd like to give our panel a round of applause. I think they did a wonderful job tonight.